Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 23, 2025, which was about 4 days ago. The big hook is a data-free way to stop catastrophic forgetting by merging models through their internal representations so knowledge gets aligned rather than overwritten. The paper is titled, Recall, Representation-Aligned Catastrophic Forgetting ALLeviation via Hierarchical Model Merging. And, as we will see later, the implications for model training are quite significant. In short, this paper computes layer-wise similarity on clustered typical samples and then fuses parameters hierarchically, preserving shallow general features while letting deeper layers adapt across multiple tasks without using past data. Alright, Figure 1 shows a simple taxonomy that contrasts replaying old data with changing the model itself to resist forgetting. On the left, data-based methods replay cached samples during fine-tuning, which works but needs storage and raises privacy concerns. The center cartoon illustrates regularization that steers updates toward a shared, low-loss region so prior skills survive. On the right, architecture-based methods route tasks to separate expert modules, which isolates knowledge but adds complexity. Well, Figure 3 visualizes how two fine-tuned models drift apart in their internal representations, which means their hidden state geometry changes even for the same input. Representation drift is the shift in where samples cluster inside a model's feature space. The left circle at layer 15 shows broadly similar clusters. The right circle at layer 32 shows separated clusters and split trajectories toward different outputs. So naive parameter averaging would clash, and alignment by layer becomes necessary. So, Figure 2 shows that hidden representations shift unevenly across the network, which means layer-specific behavior must be respected during merging. A hidden representation is the model's internal summary of the input, and its geometry signals what the model has learned. The left inset at layer 0 displays mixed clusters that capture broad features. The middle inset at layer 15 reveals clearer structure as features specialize. The right inset at layer 32 shows sharply separated clusters, so deeper layers carry highly task-specific signals. Alright, Figure 4 presents the recall pipeline, showing how layer-wise alignment guides safe parameter merging across models. The left block extracts hidden states from a small set of typical samples, which means a handful of representative inputs that stand in for the dataset. The center computes similarities for each layer across models, so weights reflect where representations agree. The right side then merges parameters hierarchically, preserving shallow shared features while allowing deeper layers to stay task-specific. Alright, Table 1 summarizes single model merging, and the results show that representation-aligned merging leads across datasets without using past data. Unseen tasks means the evaluation excludes the dataset used to fine-tune the expert. The method reaches an all-task average of 45. The unseen task average is about 39. These results beat the strongest baseline by roughly 6%. The margin on unseen tasks is about 8%, which signals strong transfer without catastrophic forgetting. Wrapping up, two takeaways stand out. Representation-aligned, per-layer merging curbs catastrophic forgetting without needing past data, and the shallow versus deep layer split lets models keep general skills while integrating task-specific expertise. The broader implication is privacy-friendly, scalable maintenance of multi-domain systems through safe model fusion. That is it for the AI Research Roundup. I am Alex. Thanks for listening.